4.9 Approximation Techniques. Okay, so the first approximation method we're going to learn is Newton's method. Newton's method is a root finding algorithm. And one of the most important ones ever discovered. All right, so let's take a picture and try to explain what's going on with this algorithm. All right, there's a function. Looking kind of sloppy accidentally there. Okay, good enough. And here's a root. It's got an x-intercept. Let's just call it a. We like to know approximately what a is. So one way to try to find that is to pick a, what you call an initial guess. Okay, so I'm going to start over here, pick this number. I don't know what it is. All I know is it's further down the road than a is. Okay? So we're going to call this x0. Okay? x0 is an initial guess. Right. And the idea is to then look at where that maps up to the function. Okay? So obviously that point right there is x naught, f of x naught. Right? And then to look at the tangent line there, something like that. And then see where that tangent line intersects the x-axis. It will be closer, right? This is closer to a than the initial guess was. Okay? And we're going to call this x1. It's the next x down. Okay? I'm going to repeat this process. We're going to map x1 up to the curve. Okay? Here it is. And that's going to be x1 comma f of x1. We're going to draw another tangent line. We're going to inspect where that tangent line intersects the x-axis. Good enough. And that's going to be x2. It's pretty clear that as we iterate this process, we continue doing this process over and over again, the x values we find along the x-axis, the roots of these tangent lines, will be closer and closer to the value of a that we're trying to approximate. Okay? So in other words, each of these is an approximant to a, and it's just going to keep getting better and better as we iterate through this geometric process. Right? What we need to do is write this out in some sort of algebraic way so we can actually calculate these things. But this is the geometric understanding of Newton's algorithm. Okay? So let's try to write out what this will look like algebraically speaking, and perhaps get a formula.